Let's dive a little deeper into this by focusing on AI assistants, likely the EverWorker type you're most familiar with. Again, think of tools like OpenAI's ChatGPT, Anthropic's Claude, or Google's Gemini. These are powered by large language models, or LLMs, which provide their impressive chatbot capabilities. As you can see on the graph, AI assistants typically handle tasks of lower complexity and operate with a lower level of autonomy. When thinking about human knowledge work, they primarily provide human question, AI answer assistance. Even at this stage, many of us have seen how they can dramatically boost individual productivity and effectiveness by helping to accelerate and simplify various tasks. So, let's take a moment to return to thinking about AI assistants and human knowledge work. For those people working in deterministic roles, AI assistants can rapidly provide information, clarify procedures, and essentially help individuals make faster, more accurate, rule-based decisions. For knowledge workers engaged in non-deterministic tasks, assistants are invaluable for accelerating research, drafting initial ideas, summarizing complex documents, and ultimately helping humans analyze options to inform their strategic or creative decisions. They assist rather than make the final call. So, what does the basic architecture of an AI assistant look like? At its heart is a large language model, or LLM, which is the engine or brain for understanding and generating language. This LLM is then enhanced and guided by three key components: instructions, which tell the AI what to do and how to behave; knowledge, which provides the information it can draw upon, including specialized or proprietary company data accessed through techniques like retrieval augmented generation, or RAG, and actions, which allow the LLM to interact with other systems and perform real-world tasks. We'll be diving deep into each of these, LLMs, instructions, knowledge, and actions, in subsequent modules, as they are the fundamental building blocks for creating effective AI solutions. Moving up in autonomy and complexity, we have AI agents. These EverWorkers are semi-autonomous systems designed for end-to-end completion of specific multi-step tasks. Their strength lies in automating well-defined, deterministic processes, the kind of work that follows clear rules. AI agents don't just follow steps. They autonomously execute predefined business tasks based on those established rules. Think about processing standardized applications, intelligently routing support tickets based on their content, or managing the sequential steps and decisions in an HR onboarding process. All of these have rules and correct procedures that must be followed. By taking over these routine operations and their associated decisions, AI agents deliver significant business value through enhanced efficiency and consistency. The architecture of an AI agent, as shown here, is naturally more complex. It often involves a sequence of task steps. Each step might involve one or more large language models, each potentially with its own specific instructions, knowledge sources, and actions. Workflow logic is key here, enabling the agent to progress through the tasks, making conditional branches based on pre-programmed decision points and rules. You can see how an agent might progress through task step 1, task step 2, and so on, even incorporating error handling. This allows an AI agent to manage a complete multi-step process from beginning to end, orchestrating various AI capabilities to achieve a defined business outcome. At the forefront of EverWorker capabilities are AI workers. These are highly autonomous decision makers. They are designed to perform autonomous execution of complicated tasks, often involving making their own autonomous decisions to achieve some kind of consistent outcomes. The goal here is to enable humans to delegate entire decision-making roles or complex job functions to an AI system. This is the long-term opportunity we're moving towards. For complex deterministic roles, AI workers can take the reins, fully managing very complex functions that require significant rule-based or even tactical decisions. They become the accountable managers in charge. Sometimes they might even manage other sub-AI agent systems. Imagine advanced compliance monitoring that not only flags issues, but also initiates corrective action. But their power extends further. For humans engaged in non-deterministic roles, AI workers act as incredibly powerful collaborators. They can handle delegated decision-making for complex tasks and workflows, perform sophisticated scenario analyses, forecasting the potential outcomes of various strategic choices, and propose data-driven solutions. The architecture of an AI worker is, as expected, the most sophisticated. It entails complex workflow orchestration, often involving numerous LLM interactions. A critical feature highlighted in this diagram is the presence of autonomous business decision nodes. At these points, the AI worker is designed to evaluate complex information, drawing on its instructions and knowledge, and autonomously choose between or even create different courses of action, perhaps leading to outcome 1, outcome 2, or outcome 3. This architecture supports dynamic pathing based on these decisions, incorporates robust error handling, and is often designed for iterative improvement. The ultimate aim is to enable organizations to confidently delegate significant job functions or complex decision-making responsibilities to these highly capable AI systems.